Hi, my name is Imani Hall, and I'm a product manager for Azure Storage. Today I'll be doing a product demonstration of one of our newest offerings, Customer Managed Planned Failover. First, I'll begin by giving some background context on what exactly planned failover is. I'll also provide a bit of context about our other feature, unplanned failover. From there, I'll do a comparison of both planned versus unplanned failover. Finally, I'll conclude by doing a demonstration of planned failover and also planned failback. What is planned failover? Planned failover is a disaster recovery solution that allows users to swap their primary and secondary region while their storage service endpoints are still healthy. As a result, a user can now fail over their storage account while keeping geo redundancy and without any data loss or additional cost. A user will no longer need to reconfigure geo-redundant storage after their failover operation is completed. This saves customers both time and cost. Once the planned failover operation is completed, all new writes will be made to the original secondary region, which will now be the new primary region. There are multiple use cases for planned failover. One use case for planned failover is planned disaster recovery drills that help businesses to validate their business continuity in disaster recovery. Another use case for planned failover is recovering from partial outages that occur in the primary region where storage is not impacted. On the other hand, we also have unplanned failover. Unplanned failover is a disaster recovery solution that allows users to restore access to their storage account during storage-related outages. If the storage service endpoints in a user's primary region becomes unavailable, they can initiate an unplanned failover to the secondary region. After the unplanned failover is completed, the data in the original primary region is erased, the account is changed to locally redundant storage, also known as LRS, and your applications can resume writing data to the storage account. There are multiple use cases for unplanned failover. These use cases include if the storage service endpoints in your primary region are unavailable, causing read or write failures. Another use case is an Azure advisory in which Microsoft recommends that a storage account failover is performed due to an outage. Another use case for unplanned failover is also disaster recovery testing. What are the differences between planned and unplanned failover? When we look at unplanned failover, the storage account is converted to locally redundant, or LRS, after the failover operation is completed. With planned failover, the storage account remains geo-redundant after the failover operation, meaning that the account no longer loses geo-redundancy. Another major difference between unplanned and planned failover is the fact that there is no data loss. When an unplanned failover is initiated, the operation begins almost immediately. Writes that are pending replication to the secondary region will potentially be lost. Users can utilize their last sync time to determine the recovery point of their storage account. On the other hand, once a planned failover is initiated, the first step is replicating pending writes to the secondary region. As a result, the last sync time is caught up and there is no data loss. One of the primary use cases of unplanned failover is a storage-laden outage in the primary region. On the other hand, one of the primary use cases for planned failover is non-storage related outages in the primary region. Unplanned failovers can be initiated when the primary storage service endpoints are unavailable. This is typically caused by a storage-laden outage in the primary region. Planned failover, on the other hand, only works while the primary and secondary storage service endpoints are available. During my demonstration today, you'll see that planned failover takes some time to complete. At the moment, although Azure Storage does not provide an SLA for the planned failover completion time, planned failovers are typically completed within 1 hour. There are various factors that can impact the time it takes to complete a planned failover. These include the amount of data that needs to be synchronized between the primary and secondary region when the planned failover request is submitted. One of the first steps of the planned failover is synchronizing any writes pending replication between the primary and the secondary region. This step ensures that there's consistency between the primary and the secondary region, and is how we ensure that there is no data loss once the planned failover is completed. Another major step in the planned failover operation is changing the DNS configuration. By changing the DNS configuration, this is what allows us to swap the primary and secondary region of your storage account. Now I'll move forward with the product demonstration of planned failover. First, I'll use Storage Explorer to demonstrate the connection of an RA-GRS storage account. I'll show that the primary endpoint has both read and write access, and I'll upload a write to my primary region. Then I'll demonstrate that the secondary endpoint only has read access. I'll do this by attempting to make a write to my secondary endpoint, which will not succeed. From there, I'll initiate a planned failover through Azure Portal and demonstrate what occurs when a planned failover is initiated and also while it's in progress. You'll see the primary region temporarily loses access for both read and writes. I'll then show that any writes made between the last sync time and the initiation of the planned failover finishes synchronizing to the secondary region. I'll then show that the primary and secondary regions are swapped after the planned failover, and once the planned failover is complete, that write access is restored to the new primary region. Once my planned failover is successfully completed, I'll also show myself initiating a planned failback. From there, the original primary and secondary regions will be restored. Now that I've gone through all the steps, I'll move over to Azure Portal to show you my RA-GRS storage account. This is the Azure Portal user experience. Within Azure Portal, the failover features lie within the redundancy blade. To prepare myself for my planned failover demonstration, I went ahead and created a RA-GRS storage account in Southeast Asia. As you can see, right now, my primary region is Southeast Asia and my secondary region is East Asia. Ultimately, once the planned failover is completed, my primary and secondary regions will be swapped. As a result, East Asia will become my new primary region and Southeast Asia will become my new secondary region. Now I'll head over to Storage Explorer to move forward with the product demonstration. Now that we're within Storage Explorer, you'll see on the left-hand side, I connected my Storage Explorer to my primary endpoint. On the right-hand side, I went ahead and made a connection to my secondary endpoints. Now I'll move forward by demonstrating that my primary endpoints have read and write access, while my secondary endpoints only have read access. So going to a container that I created in my primary endpoint, I'll demonstrate that I have write access by uploading a new file to my storage account. I'll upload a test file for now. As you can see, the write was successfully made to my primary region. And now I'll demonstrate how quickly the write is replicated to my secondary region. If we take a look at the secondary region now and we press refresh, we'll see that the write is now also available in our secondary region. As previously mentioned, the secondary region only has read access. As a result, you are unable to make writes to your secondary endpoint. I'll demonstrate this now by attempting to make a write to my secondary endpoint instead. Here I'm just uploading a test image. As you can see, the write failed to be made to my secondary endpoint since it only has read access. Now that I've demonstrated this, I'll move forward with actually initiating the planned failover. First, I'll begin by uploading a folder to my storage account just so that I'm able to upload a bit more data. And while that's transferring, I'll go ahead and go to Azure Portal where I'll actually initiate the planned failover. Now that we're within Azure Portal, I initiate the planned failover by first clicking Prepare for Failover. Some of the important things to note is that you have the option of either initiating an unplanned failover or a planned failover. I'll go ahead by clicking Planned Failover. Once you click Planned Failover, you're provided with some very important details. First, you're provided with the last sync time. This is important because once you initiate the planned failover, any writes made after the last sync time will be synchronized to the secondary region before the planned failover completes. This ensures that there's consistency between the primary and the secondary, and also ensures that there is no data loss. Other important information that you're provided with is the redundancy that your storage account will be after the failover, and also what your new primary and secondary region will be. In this case, you'll see that my storage account will remain RAGRS after the failover, and East Asia will be my new primary region, and Southeast Asia will be my new secondary region. Once you confirm that everything looks good, you go ahead and initiate the failover by simply typing in yes to confirm you'd like to initiate it. And now your failover request is submitted. As I previously mentioned, the failover operation typically completes within 1 hour. So while this is in progress, I'll also demonstrate the fact that your primary region is made locked for writes to allow the synchronization between the primary and the secondary region to complete. I'll demonstrate this by heading back over to Storage Explorer where I'll attempt to make a write to my primary region, which is now locked for writes. Before demonstrating that my primary region is now locked for writes, I'll also demonstrate that the test folder that I uploaded right before I initiated my planned failover was successfully synchronized to the secondary region. As you can see, my test folder that I uploaded right before the planned failover has successfully synchronized to my secondary region. As a result, the primary and secondary region are now synchronized. Now I'll move forward with demonstrating that my primary region no longer has write access. As you can see, this is the primary region where I previously successfully made writes to. I'll attempt to upload a new file now. As you can see, the write that I attempted to make to my primary region has failed. This is to allow the synchronization between the primary and the secondary region to complete and to ensure that there's no data loss once the planned failover is completed. Now I'll return once the planned failover has completed so that I can show that the primary and the secondary region have successfully been swapped. As you can see, my planned failover has now completed successfully. Two important things to note is that after the planned failover is completed, you're provided with a timestamp that tells you the exact time that your planned failover completed. Another important thing to take note of is that you can see that my primary and secondary regions were successfully swapped. East Asia is now my new primary region, and Southeast Asia is now my new secondary region. I'll head back over to Azure Storage Explorer now to demonstrate that the write access has been successfully restored to my primary endpoint. Now that I'm within Storage Explorer, I'll go ahead and attempt to upload a new file to my primary endpoint. As you can see, write access has been successfully restored to my primary storage account. I'll also demonstrate that the write has successfully been replicated to my new secondary region. As you can see, the write was successfully replicated to my secondary endpoint as well. Now that I've demonstrated how to initiate a planned failover and also shown that the write access has been restored, I'll move back over to Azure Portal where I'll demonstrate how to initiate a planned failback. Initiating a planned failback is really simple. All you have to do is follow the exact steps that you did to initiate a planned failover. Once the planned failback is completed, my original primary and secondary regions will be restored, meaning that my primary region will go back to being Southeast Asia and my secondary region will go back to being East Asia. When you go to prepare for failover and you select planned failover, you're also provided this information once again. The information provided details the fact that your storage account will continue to be RAGRS once the planned failover is completed, and that your primary region will be Southeast Asia and your secondary region will be East Asia. So I'll go ahead and confirm that I would like to begin my planned failover. Now that my request to initiate my planned failback has been submitted, I'll return once the planned failover is completed to demonstrate and show that my new primary region is Southeast Asia and my new secondary region is East Asia. Now that my planned failback has completed, you'll see that my original primary and secondary regions have been restored. You'll also see that I'm provided with a timestamp that shows me when my planned failback completed. And that now completes my demonstration of a planned failback. Thank you all for taking the time to watch this product demonstration of planned failover.